What's different about this problem? Mass. Scotty?
That's double this one. Wait, no, sorry. Combustion.
It is a combustion. Good. We're looking for mass. It's combustion. What else is different about it? What are we starting with that's different? Grams. We're looking for grams, right? Yeah, we flipped over to the next page. Sorry. Okay, so mass. What unit do you think of when you hear the word mass? Grams. Yeah, exactly. So we're looking for grams in this problem. In the other problems, we were just looking for moles, right? So this is going to be our first longer problem, all right? We're still going to start with what's given, right? We're still going to start with 0.85 grams of butane. Now, using context clues, what's butane's formula? Right, it's the only thing from the equation that you don't know. C4H10, because you know oxygen, you know carbon dioxide, you know water. Good. Okay, what do you think our first step is here? What are we going to convert this into? So right here we have grams, C4H10. What are we going to convert that into first? Yeah, moles. Moles of what? The same thing, yeah, C4H10. Once it's in moles of C4H10, then what can we convert it into? Not grams, Scotty? Moles of, yeah, what it's looking for, the carbon dioxide. So moles of carbon dioxide. This is the new thing for this chapter. This is what we just did, right? Going from moles of one thing to moles of something else, right? This was last chapter, going from grams of the same thing to moles of the same thing. So that's last chapter. This part's the new chapter. And then once we have moles of CO2, what do we have to convert that into? Grams of CO2, right? Yeah, grams of CO2, because that's what it asked for. So this flow chart is the steps that we're going to take today, all right? We're going to start with grams of C4H10. How did we know that? It's what was given, all right? So we start with the given, and then you have to convert it to moles, because this chapter, the switch happens in moles, right? The ratio switch we just learned about. And then once we're in moles of CO2, which is sort of what we're looking for, we have to convert it to grams of CO2 because it told us to, all right? If it asked us to convert it to molecules or something, we could do that as well, right? But we'll talk about that in a minute. Okay, so let's do this. What's going to go on the bottom here? Grams of C4H10. And what's going to go on the top? Moles of C4H10. Okay, what's the molecular mass of C4H10? What is it? 58.14. Does everyone agree with that? I agree. I think it's fine. We'll find out in a minute, right? Comment below if it's wrong. All right, so so now we have grams cancel out. All right. And now we have moles, right? Hey, here's a weird question. Why is it 1 mole? Remember we were saying before you look at the equation, why is this one only 1 mole though? Yeah, Scotty?
Because 1 mole equals to mole mass.
Yeah, exactly. Remember the mole flow chart? It was 1 mole equals a molecular mass. So this part's last chapter, right? So you can't change what we learned last chapter. This is always going to be 1 mole and then the grams, all right? Whenever you have moles in something different, it's going to be 1 mole and then whatever the something different is. Now in the next step, where it's going to be moles and moles, that's where you use the equation above. So let's do that one. On the bottom, we know it's going to be C4H10 because C4H10 is up here, so they need to cancel out. And then what are we looking for? That's what goes on the top. CO2, right? All right. And numbers. What's the number for CO2? Good, yeah, it's 8. And then on the bottom, C4H10 is going to be 2, right? So this is the step where you use the ratios, all right? From the equation. Okay, so we have the 8 and the 2. Are we done? Nope, we need to cancel out moles of C4H10. Now we have moles of CO2. What are we trying to convert it into? Grams, yeah, so on the bottom we put 1 mole of CO2, and then on the top, what's going to go on the top? 44. Good, 44 point what? 01. Grams of CO2. All right, good, and then we'll have moles, moles. And now we multiply across, we divide to get our answer. And then from the calculator, you'll get 2.57. But with sig figs, what do we have to do? We have to round it just to 2, because 0.85 has 2 sig figs. So this will be rounded to 2.6 grams of CO2. Okay, are we good? Okay, let's look at this for a second. In the beginning of the problem, we made this flow chart up, and if you notice, the flow chart went from grams of whatever you start with to moles of whatever you start with. Then you switch from moles of the starting material to moles of the product or the finishing material, whatever you're looking for goes here. And then you go from moles to whatever they're asking you to do, okay? Bless you. So in this chapter, the beginning's going to be different depending on what they give you. The end's going to be different depending on what they're asking for, but the middle will always be the same. It'll always be moles of one thing to moles of the other thing. All right, that's the new thing this chapter. Another cool thing with this flow chart is, if you take a look here, it's everything that's on the top, right? So grams of this, moles of CO2, grams of CO2. So if you can do the flow chart, you know what goes on the top. And of course you know what's on the bottom, because just like last chapter, if it's over here on the top, then it's over here on the bottom, right? Because they need to cancel out. So that's how you kind of like figure out what everything's going to be. All right? Any questions?